Alright, let's talk about flow rate. So flow rate, represented by the letter Q, or the variable Q, is how much fluid flows through an area in a given time. So visualize a pipe, right? And we're talking about how much fluid is going to pass through a certain part of that pipe over a certain amount of time. So our equation for that is Q is equal to A times V. So our flow rate is just equal to the cross-sectional area of that pipe times the velocity of the fluid through that pipe. So here we can see our example. Cross-sectional area, we're talking about if I cut through that pipe, what is the area that I see, the circular usually, area of that pipe? Okay, so let's look at an example. If the area of this pipe is 2 square inches and fluid flows through the pipe at 10 inches per second, what is the flow rate? Well, we know our area, it's 2 square inches. We know our velocity, it's 10 inches per second. So I'm just going to multiply those two things, those two values, and I get that the flow rate is 20 inches cubed per second. Remember, when we multiply the numbers, we're also multiplying the units. So inches squared times inches over seconds leaves us with cubic inches per second. So this works out as volume per time. That's exactly what flow rate is telling us about. So that's your basic problem in flow rate, but often they're going to be a little bit more difficult than that. You probably won't be given the area. You might be given the diameter or the radius of the pipe, and then you'll have to calculate the area from there. So make sure you know your circle equations. Alright, so let's try a little more advanced problem. Let's say we've got this faucet. You're trying to fill up a bucket in your house, and the faucet, let's see what we got here. The faucet has a diameter of 1 inch. Okay, so we're given the diameter here, not the area. That means we have a little work to do first. And the water flows through the faucet at 6 inches per second. So we want to find out how much water will be in the bucket after 20 seconds. And this problem looks a little different than the last one we did, right? I'm not asking for the flow rate explicitly, but I'm asking for how much water is going to be in the bucket. So we have a couple steps here. First thing, we're going to calculate our flow rate, but we need to know the area of our faucet. So to do that, remember area is pi r squared. So I take pi, the radius is the diameter divided by 2, so 1 inch over 2. Square that, multiply by pi, I get 0.9 square inches. Now I can plug it into my flow rate equation. Multiply by the velocity, so I get my flow rate is 4.7 cubic inches per second. But wait, the question didn't ask for flow rate, it asked for how much water will be in the bucket after 20 seconds. So if this is how much water is flowing through per second, then all I need to do to figure out how much water is in there after 20 seconds is multiply the flow rate times the time. So 4.7 inches cubed per second times 20 seconds leaves us with 94.3 cubic inches of water, which, if you're curious, is about 1.55 liters of water. Alright, let's try one more example. This one's, again, slightly different. We've got a pipe that starts out a little wider and then narrows. So we've got a different area at the beginning than we do at the end. That means the velocity is going to change also. The flow rate here is going to be the same at either point, because the amount of liquid that exits the pipe is going to be the same as the amount of liquid that enters the pipe. So our flow rate has to be the same at any point in the pipe. So if Q1 is going to equal Q2 in this situation, then we know that A times V for the first position is going to be equal to A times V the second position in the narrower part of the pipe. So let's take some values into this. If we consider the pipe above, we know the first part has a radius of 3 inches, second part has a radius of 1 inch, and we know the velocity at the beginning, so at the wider part of the pipe. We want to find the velocity at the narrower part of the pipe. I'm going to let you try this one on your own. So get out a piece of paper, see if you can plug in the values correctly. You're going to need to find area first for both parts, the wide part and the narrow part, and then you're going to solve for V2. Now I'm going to give you the answer here, so if you want to pause it and not see it, pause it now. Right? For those of you who are not pausing or who have already paused and have come back, welcome back. Here's your answer. You should get a velocity of 900 inches per minute. If you got it right, congratulations. Make sure you check out the other fluid power videos if you haven't already, and I hope this was helpful.